Image Processing and Computer Unit 4 according to RGPV Exam 2023 notes are in comment. Explain Facet Model Recognition. Labeling lines, understanding line drawings, classification of shapes by labeling of edges. Facet model recognition is a technique used to recognize and classify 2D line drawings or sketches into different shapes based on the labeling of edges. This technique involves several steps, including labeling lines, understanding line drawings, and classifying shapes based on the labeling of edges. 1. Labeling lines. In the first step of facet model recognition, lines in the drawing are labeled based on their geometric properties, such as length, orientation, and curvature. 1. These labels provide information about the shape and structure of the lines and are used to group similar lines together. 2. Understanding line drawings. In the second step of facet model recognition, the labeled lines are analyzed to understand the underlying structure of the drawing. 2. This involves identifying the vertices and edges of the drawing, as well as any symmetries or regularities in the shape. 3. Classification of shapes by labeling of edges. In the final step of facet model recognition, the labeled lines and the underlying structure of the drawing are used to classify the shape into a predefined set of categories. 3. This is done by matching the labeled lines and the structural information of the drawing with a database of known shapes. The labeling of lines is an important step in facet model recognition, as it provides a basis for understanding the underlying structure of the drawing. Different labeling schemes can be used depending on the application, such as using angles or curvature to label lines. Understanding the line drawing involves identifying the vertices and edges of the drawing and extracting any relevant features, such as symmetry or regularity. Finally, the classification of shapes based on the labeling of edges involves matching the labeled lines and structural information of the drawing with a database of known shapes. This can be done using various techniques, such as machine learning algorithms or rule-based systems. In summary, facet model recognition is a technique used to recognize and classify 2D line drawings or sketches into different shapes based on the labeling of edges. This technique involves several steps, including labeling lines, understanding line drawings, and classifying shapes based on the labeling of edges. Facet model recognition can be used in various applications, such as in computer-aided design, CAD, or in the recognition of hand-drawn sketches. Explain recognition of shapes, consisting labeling problem, backtracking algorithm, perspective projective geometry. Shape recognition is the process of identifying the shapes or objects present in an image. The recognition of shapes involves several steps, including the segmentation of the image, feature extraction, and classification of the shapes. One of the main challenges in shape recognition is the problem of shape labeling. 1. Consisting labeling problem. The shape labeling problem refers to the task of assigning labels to the shapes in an image based on their properties. 1. For example, a square can be labeled as a rectangle, but not all rectangles can be labeled as squares. 1. The shape labeling problem can be solved using various techniques, such as graph-based approaches or statistical methods. 2. Backtracking algorithm. One technique used to solve the shape labeling problem is the backtracking algorithm. 2. This algorithm involves searching for the best labeling solution by iteratively testing different combinations of labels until a valid solution is found. 2. The backtracking algorithm can be used for shape labeling in both 2D and 3D images. 3. Perspective projective geometry. Another important aspect of shape recognition is the use of perspective projective geometry. 3. This involves modeling the 3D world as a 2D projection and using geometric transformations to map points in the image to their corresponding points in the 3D world. 4. Perspective projective geometry is essential for recognizing shapes in images captured from different viewpoints. In summary, the recognition of shapes involves several steps, including segmentation, feature extraction, and classification. The shape labeling problem is a key challenge in shape recognition, and techniques such as the backtracking algorithm can be used to solve this problem. Perspective projective geometry is also important for recognizing shapes in images captured from different viewpoints. Shape recognition has many applications, such as in robotics, autonomous vehicles, and image analysis. Explain inverse perspective projection. Photogrammetric from 2D to 3D. Inverse perspective projection is a technique used in photogrammetry to create 3D models from 2D images. This technique involves using geometric transformations to map points in the image to their corresponding 3D coordinates in space. The inverse perspective projection is often used in computer vision and robotics applications to estimate the position and orientation of objects in 3D space. The photogrammetric process involves taking multiple images of an object from different viewpoints and using the inverse perspective projection technique to reconstruct a 3D model. The process begins with the calibration of the camera, which involves determining the intrinsic and extrinsic parameters of the camera. The intrinsic parameters include the focal length, sensor size, and distortion coefficients, while the extrinsic parameters include the position and orientation of the camera in space. Once the camera is calibrated, the images are processed using the inverse perspective projection technique to map 2D image points to their corresponding 3D coordinates in space. This involves first determining the position and orientation of the camera relative to the object, and then using the camera projection matrix to transform the 2D image points into 3D coordinates. The resulting 3D points can then be used to reconstruct a 3D model of the object. Inverse perspective projection is a powerful technique for creating 3D models from 2D images, but it has some limitations. One of the main challenges is dealing with occlusions, where parts of the object are hidden from view in some images. This can result in incomplete or inaccurate 3D models. Additionally, the accuracy of the 3D model depends on the quality of the camera calibration and the accuracy of the inverse perspective projection algorithm. In summary, inverse perspective projection is a technique used in photogrammetry to create 3D models from 2D images. This technique involves using geometric transformations to map points in the image to their corresponding 3D coordinates in space. The resulting 3D points can then be used to reconstruct a 3D model of the object. Inverse perspective projection has many applications, including in robotics, computer vision, and virtual reality.